Okay, so we have a midterm in this time. So this is the same time for the class, and the range of the midterm is so the contents that covered by lecture note 1 to 3. So this is the midterm range. Okay. So that means we have to finish lecture note 3 before the midterm. So we don't have that much time. Okay, so let's start. Okay, so up to this point, we have discussed about the discrete random variable, right? Discrete random variable. The definition of the discrete random variable is if its sample space is a discrete set, then it's a discrete random variable. It's like the flipping a coin or rolling a dice. Those are the discrete random variable. And common random variable is like the Bernoulli random variable. That's a discrete random variable. And there is another set of random variables that is continuous random variable. And continuous random variable is as it is. The sample space is the continuous set. The example is waiting time. Waiting time for a bus. Bus can arrive in a minute, but it can take 30 minutes. So it's a kind of the random variable. And the waiting time for a bus is continuous. It can be 10 minutes or 10.1 minute, 10.0001 minute. So any value, any non-negative value can be a waiting time. So in that case, sample space of Sy is usually given as y that y is less non-negative y. So they are given in this way. So y is continuous, then the random variable y is continuous random variable. Okay? Okay, further, the discrete random variable. This random variable x is fully defined by its Pmf, probability mass function, or equivalently CDF, cumulative density function, right? The PDF is fully defined by Pmf, which is Px of x is probability that x equals certain value x, or CDF, cumulative density function, large fx, which is probability of x is less than or equal to certain value of x. So this, a random variable x is fully defined by Pmf or CDF. So for the continuous random variable, it's very similar. For continuous random variable x, this one is also fully defined by CDF. First, CDF. Then in this case, CDF is the same. The definition is the same. Fx of x is probability that x is larger than or equal to, less than or equal to a certain value of x. This is the definition of the CDF for the continuous random variable. And it's the same for the discrete random variable. Okay? So let's think about okay, so let's think about the waiting time. Let's think about x is a waiting time. Time for a bus. Okay? Then what would be the probability of x less than or equal to minus infinity? 0, right? Because there's no such a thing, right? So it is 0. So how about that? Probability that x is less than or equal to infinite. It's 1, definitely, because the whatever value should be less than or equal to 1. That means for the CDF, the property of the CDF is first for the whatever the CDF of x, CDF of the minus infinity is always 0 because the nothing can be less than minus infinite. And definitely, if fx of the positive infinity is 1, because everything should be less than infinite. So this property is exactly same property of the same with the property of the discrete random variables. Is it right? So the CDF of the continuous random variable and discrete random variable, they are equivalent. They are the same because the definition is the same. Okay? And how about this? And the second property, so let's think of the x is waiting time for a bus. Then, if you compare the waiting time, the probability of the waiting time is less than 10, compared to this probability and probability that waiting time is less than or equal to 11. So, first probability is, my waiting time for a bus is less than or equal to 10. So bus is gonna be arrive in 10 minutes. And the other probability is waiting time is less than or equal to 11 minutes. That means bus is gonna arrive within 11 minutes. Which probability is gonna be larger? This one is larger, definitely, right? Because this one includes this one. So in general, for any CDF function, if b is larger than or equal to a, because of its definition, fx of b is larger than or equal to fx of a. It is, very obvious. So that means if we draw a plot of fx of x, this fx function is keep increasing, never decrease. In other words, that is monotonically increasing, but more exactly, monotonically non-decreasing, because it can be flat, theoretically. So monotonically non-decreasing is the right term. Okay, so second property is, if b is larger than a, for any b and a, fx of b should be larger than or equal to fx of a. So that property also holds if you record discrete random variable. That property also holds for the discrete random variable. So CDF is exactly the same. And third one. So for b and a, b is larger than or equal to a. If we want to calculate probability that this x should be large x, so if we want to calculate probability that x is between a and b, then because fx, by definition, fx is defined in this way, this is definitely probability that x is less than or equal to b minus probability that x is less than or equal to a. So obviously, that means this is difference of the two CDF. So this one is a hold. So for example, if x denotes the waiting time for a bus, if we want to know that bus gonna be arrive between 10 and 11 minutes, that means probability that x is between 10 and 11. That can be calculated by probability that x is less than or equal to 11 minutes minus probability that x is less than or equal to 10 minutes. Right? It's very obvious. 자, 여러분, 네, 별거 아니죠? 네, 쉽죠? 네, 그래서 CDF가 있는데, 이 CDF는, Discrete Random Variable에서 배웠던 CDF랑 똑같다. 네, 같다고 보시면 됩니다. 네. 근데 이제 한 가지 큰 차이점. Okay, so basically, CDF in the continuous random variable is equivalent to the CDF of the discrete random variable. 다음에 보자. But one difference is, if you actually draw plot the CDF of the discrete random variable and continuous random variable, their shape is very different. Because in discrete random variable case, as you have seen, it is, the step. And they are, the discontinuous. Because in this case, this discrete random variable has probability when it is minus 0.5, and it is 0, and it is 0.5. So there's a jump. So no probability here, and probability here is jump. No probability, and this value 0 has a probability, so it has a jump here, and jump again, up to 1. Okay? However, in the continuous case, it's not like that. It is very continuous. That's the difference. The reason is, the reason is like that. So we can calculate this random variable x between 10 and 11. But also it has a small probability that x is between 10 and 10.1. So So which number you actually pick, you can find out the very, very small probability that x can fall into. So for example, if we select the very small probability, let's say in this case, between 0.4 and 0.41, in this range, this random variable also has very small probability. However, in the discrete random variable case, because if the x is not defined over in this range, it's definitely 0. However, in the continuous case, it's not 0. There's some small probability. So that's why the CDF is continuous. 그러니까 CDF가 기본적으로 정의 자체가 같기 때문에 모든 성질이 같아요. Discrete과 Continuous는. 하지만 다른 점은 Continuous Random Variable은 모든 영역에서 가치를 가질 수 있기 때문에 CDF 자체가 스무드하게, 컨티뉴어스하게 증가한다. 0에서 1까지 증가하죠. 근데 Discrete은 가질 수 있는 값들이 정해져 있기 때문에 계단 형태로 딱딱딱 증가한다. 그게 차이점이죠. Okay, so this is the CDF. Next page, please. Alright. So, okay, again, this discrete random variable. Okay, discrete random variable is fully defined by probability mass function and cumulative Pmf and CDF. And here, we haven't seen this continuous random variable also can be fully defined by CDF. Then we are curious what gonna be the something corresponding to the PMF for the continuous random variable. Okay. For the discrete random variable case, PMF is defined the probability that x is exactly equal to certain value of x, small x. However, in the continuous case, the probability that continuous random variable is x is equal to certain, certain value, exactly equal to a certain value. That probability itself is always 0. 0, right? Okay, so because because it's like that, so let's think about x is the Bernoulli random variable. Let's say 1/2. Okay, then probability of x equal to 1 is 1/2, and this probability is equal to probability that x is less than it's like so. This probability is equal to fx that 1 plus 0.01 minus fx minus fx of 1 minus 0.001. It is equal to this probability. Definitely. Right? Right? However, if x is any continuous random variable, the fx, so for example, f1 minus f1 minus 0.1, this one, let's think about some small positive value of the epsilon, and this value is if this epsilon is close to 0, this probability is close to the probability that x equal to 1, right? If this epsilon is getting to the very small number. However, in the continuous case, this probability itself is getting smaller and smaller if epsilon is getting smaller and smaller, because they are all continuous. And if this epsilon is become 0, very close to 0, this probability is just 0. Because the UC, so you may remember that my example at very first lecture, what's the probability of the Suji's weight, right? So the Suji's weight, the probability that Suji's weight is 47 kilogram, it is impossible because that means Suji's weight exactly equal to 47 kilogram itself. It should be 47.0001. Then it's not the probability. It's not that probability, right? So basically, in the continuous random variable, the probability that certain, this random variable is equal to certain number is 0. 자, 여러분 이해하시겠죠? 네, 그러니까 그 continuous random variable에서 어떤 랜덤 베리어블이 어떠한 값과 같은 확률은 0이에요. 예, 나올 수가 없죠. 그렇습니다. So because of that, we need to derive another function rather than this, the probability mass function instead of this probability mass function. Okay. So then, let's do some, the mathematics, simple mathematics. Okay, so for the random variable x, for a random variable x, we are interested in probability that x is between small x and small x plus delta. We are interested in this probability. Okay? And this probability can be calculated by difference of CDF. So fx of x plus delta minus fx of x. Is right? 여러분 그냥 정의에 의해서 이렇게 되죠? Okay, then this one is can be rewrite. This one is equal to divided by delta times delta. And let's think of delta is the non-negative small value, the positive small value, because I divide by delta and multiply by delta, so it's the same thing. Okay. So that means, okay, so let's think about this one. That means if our, the PDF, CDF is like this, then this one is x and x plus delta, and this probability is that x is between x plus delta. This probability, this is this probability. So if I want to recalculate fx, this one can be approximately, I actually add all of these small steps from the negative infinity to the certain value of x. That means all of x that less, all of u that less than x, I actually keep summate this one. So this probability, that is this one. So fx of u plus delta minus fx of u divided by delta and delta. Okay, so does it make sense? So in this situation, in this equation, let's send this delta to the 0. So let's consider delta is a very, very, very small one. Then this one is very, very, very small. Then we summate the infinitely many of this difference. That is corresponding concept of the integral. So this one is, if the delta goes 0, then this one become integration from minus infinity to the certain value of x for some certain function of f, small f of, let's use du. And we can express this summation as the integration, and here this small f become derivative of this large f. So right, so if we send delta to 0, this fx can be expressed by some integration of small fx, and this small fx is fundamentally becomes derivative of the large fx. Okay? So this small fx, which is defined by a derivative of the the CDF of random value of x, this one is we call probability density function, PDF, which is corresponding to the Pmf of the discrete random variable. So here, okay. So here, this continuous random variable is also defined by PDF fx of x, which is derivative of CDF. Okay, so if we summarize it, discrete random variable is defined by either CDF or equivalent to Pmf. Similarly, this continuous random variable is defined by CDF or equivalently PDF. So if we know the CDF, we can calculate PDF by taking derivative, differentiate it. And if we know the PDF, we can easily calculate CDF by integrate the PDF. So CDF and PDF, they have the same information for the random variable. As like this PMF and CDF have the same information for the random variable. So they are equivalent. Okay? But this is the difference. But this one and this one, Pmf and Pdf is definitely, they are different. First, Pmf is probability mass function, and Pdf is probability density function. Do you know what's the difference between mass and density? Mass is, the real property, right? However, density is something relative property, right? Relative to the, certain, how can I say that? It is divided by, the certain something, the certain interval. So that's a density, and this is a real probability. So Pmf is interpreted as real probability. But Pdf is not the probability at all. It's not probability. It's a density of the probability. Can you see the difference? Probability mass is a real probability. Probability density is not the real probability. Okay? So, 넘어가 볼까? Yes, so that's very important. So fx, so the PDF is not the real probability, but there's some typo. Fx, okay, so it's like that. So, 저렇게 표시되어 있니? There's a typo. This is a typo here. This is a typo. Actually, fx is a density. However, fx times delta x sum, if we assign the small interval of x, then this is the probability. This is a probability mass. However, fx itself is a density. So if we want to make it density as a real probability, we have to multiply interval of x. So that is interval of x. Okay? So in the CDF, so it's like in the CDF, let's think of this is a CDF, fx of x. Then fx at some point of x, fx is, because it's a derivative, it's a slope of this curve. Right? This is the fx. So this slope itself is not probability. So in order to make it probability, we have to multiply. Let's go, this is a delta. So this is x plus delta. So usually this probability is approximately calculated by fx times delta, because fx is a slope. Then this height, the increment, is calculated by usually this one. Density times interval. Then this is a real probability. This is a probability mass. So it's the same concept between derivative and the integral. Okay? So it's like that. So for example, let's think about this is the PDF of x. PDF of x. Then this shaded area. This shaded area is calculated by. Okay, so let me write this. Okay, similarly, let's think about this. This function is CDF, not the CDF, PDF, fx. Then this value itself is not a probability. Probability is area under this curve. So let's think of it. This is fx1, this is fx2. This area is the probability that x is between x1 and x2. Because how we calculate this one? In order to calculate, the area of this one, it is integration between x1 and x2 of f(x) of x, right? This is the way to calculate this area, and this one is minus infinity to the x2 of f(x) dx minus infinity to the x1 f(x) of dx. Right? So this is this area minus this area. So this one is equal to f(x) of x2 minus, by definition, f(x) of x1, which is this probability, which is the probability of x is between x1 and x2. So this is the concept of the probability density function. 자, 그러니까 PDF 사실 어렵지 않아요. 네, 뻔하죠. 네, 그냥 CDF가 있고 CDF가 컨티뉴어스 하니까 그 매스 펑션, 그러니까 특정 프로버빌리티를 지정할 수 없죠. 그래서 그 대신에 우리가 덴시티를 쓴다. 매스 대신 덴시티를 쓴다. 그래서 서메이션으로 됐던 게 이게 인테그레이션이 된다는 뜻이죠. Okay. So I think the concept of the PDF is not that difficult, and to get more understanding for the PDF, let's try this example by yourself. So we have, I will give, how much time would be good? 5 minutes. Okay? Then please try this example by yourself. Here is one more. So for any PDF, f(x), what's the value? So if we integrate from minus infinity to the infinity, what's going to be this value? Oh, I already write. This should be 1, right? The integrating from everything means probability for everything. That is always 1. So it is 1. 자, 요거 한번 풀어보세요. 그럼 나와서 풀어보세요. 네. 자, okay, so I think that example is not that difficult, so very obvious. So 여기 6이라는 학생이 한번 풀어보도록 하겠습니다. 자, 설명을 하시면서 기본적으로
x 범위가 0보다 작거나 커야 되니까 0부터 무한대까지 fx를 미분파에 접근했을 때 이게 1이 돼야 합니다. 그래서 이걸 미분파에 접근하면은
if you solve this one, then answer gonna be
8C가 됩니다. 8이 아닌가요?
What's the right answer? 4C. Yeah.
C가 4분의 1이 됩니다.
Okay, so let me explain in English. So basically, if you integrate this PDF over the whole range, that is from negative infinity to the infinity, that should be 1. However, in this function, if x is less than 0, if x is less than 0, the fx value is all 0. So we just do our integration from 0 to infinity. Then, if you calculate this integration, that's gonna be this kind of the function. That should be, if you calculate this one, that is for c, and it should be 1. That's why c is 1 over 4. Okay? And next. 다음 거 한번 해보세요.
그래서 A1에는 0부터 무한대까지 보냈는데 이걸 이제 그냥 부정적분 하면은 이게 2분의 1 x 마이너스 2 t 마이너스 x 이렇게 나오는데 이제 이거를 이게 아니라 0부터 x까지 이분하면은 이렇게 나오고 뒤에 마이너스 4가 마이너스 4 1인가요? 1이
Something similar, I think. Okay, so basically, if you solve this integration, I guess this minus n plus 1 minus 1 over 2 x minus 2 e to the minus x over 2 plus 1. Is it right? Which one is right? Indefinite integral. What's the indefinite integral? No. It should be interval because fx is probability that x is less than small x. That is integration from minus infinity to the certain value of x and of the fx of x. So if you calculate this one, okay. So here let me get back. So basically, okay. So 이름이 뭐였죠? 네. 네, 6이라는 학생. Okay, 6이라는 학생. So let's think about the two cases. First, if x is less than 0, what's the CDF of x? If x is less than 0, 0. Okay, and if x is not negative, less than or equal to 0, then what's the CDF? Integration of the x. So basically, fx is, if you write formally, it should be 0 if x is less than 0, and it should be from 0 to infinity of the fx of dx when x is larger than or equal to 0, and this one is here. This one is here. Okay? 0 to not infinite. Good job. Should be you. Okay? And if you calculate this one, it might have this one. Okay? 네, 잘하셨어요. 네, 박수. It's not that difficult. Okay, so how you can solve the C probability that x is between 0 and 4? So CDF fx of 4 minus fx of 0. Okay, so because you know the fx, you can easily calculate this one, and similarly, you can calculate the number d. So it's very easy, and this calculation is high school level, because it takes integration. So maybe freshman level of the, Right now we have, the college level of the mathematics integration. 여러분 보통 고등학교 때 적분 배우죠? 미적분. 근데 이제 보통 외국 케이스는 네, 우리나라만 미적을 고등학교에서 배우고요. 일반적으로 이제 대학을 들어와야지 이제 미적을 배우죠. 다른 데서는 이제 미적 안 배우죠. 맞아요? 아, 그래요? 미안해요. 미안해요. 네, 미안해요. 미국은 안 배워요. How about Turkey? So, do you guys learn integration or derivative during high school? Okay, America. You guys learn? Really? 이상하다. 안 배웠는데 옛날에는. 예. 다 배우나 봐. 그러면 오케이. This is again high school level of the mathematics. High school level. Alright. 네, high school. 네. 아, 그렇네. 안 배운다고 알고 있었는데. 어쩔 수 없죠. 네. 요새 애들이 똑똑해져가지고 점점 네, 저희 때랑 달라요. 네, 다음. Okay, so basically, so here is a comparison between Pmf and Pdf. Again, Pmf is mass, probability mass. Pdf is probability density. So, very simple. First of all, Pmf is non-negative. Definitely larger than or equal to 0 because it's a probability. And density. Probability density also should be non-negative. Because it's basically probability divided by interval of x. And the probability is non-negative and interval is also non-negative. So it is always non-negative, positive or 0. And second property, probability mass should be less than or equal to 1. Because maximum probability is always 1. How about density? Probability density. Is it should be less than or equal to 1? Is it limited by 1 or not? What do you think? No. Because it's a density. It can be goes to positive infinite. It can be very high. So this is wrong. This is wrong. This is the very important difference between density and the mass. 자, 여러분 density가 1보다 커질 수 있다는 거 이해하시겠죠? 네, 비율이니까. 그러니까 어느 순간에 그러니까 probability 집중되어 있으면 그때는 1보다 커질 수 있죠, density는. Okay. Then if we want to calculate CDF from PMF or PDF, in the PMF case, because it's the mass, we just make summation. However, in the PDF case, in the continuous random variable case, we are doing summation over continuous region. That is concept of the integration. So we take the integral from negative infinity to the x. So actually, fundamentally, this equation and this equation, they are equivalent because they are basically summation. However, for the discrete case, we added using, we say it's a sum. For the continuous case, we say it's an integration. Summation and integration, in literally, they are the same word, right? Same meaning in English. Okay. Because of this reason, if we summate all of the probability mass from negative infinity to the infinity, that should be 1. And similarly, if we integrate this PDF from negative infinity to infinity, that should be also 1. Alright? And how about this? If we want to calculate probability that x is between a and larger than equal to b, that is summation for x between less than or x between a and b, and that is calculated by fx b minus fx of a. It's the same. If we calculate this one, we use a between integration a and b, then it is calculated difference between fx b minus fx of a. So it's the same, right? But here is something, some tedious part. It's kind of the tedious part and very tricky. Is the probability that x is, let's say, between A and B. In this case, if x is continuous, this is equal to probability of A, X, and B. Because the probability that x is equal to B is 0. So this is fx of B minus fx of A. However, if fx is discrete, this one and this one, they can be deeper. They can be different. So this one is definitely calculated in this way. However, this probability, especially if x is a discrete random variable, it's not calculated in this way. So it's wrong. It can be the same, but in general, it's different. Because in here, B is not included. And definitely in the probability math, there's the probability that x is equal to B for the discrete random variable case. 자, 요 차이, 미묘한 차이는 이해하시겠죠? 네. 디스크릿 같은 경우에는 x가 b인 확률이 있기 때문에 요 확률과 요 확률이 다를 수 있다. 하지만 컨티뉴어스는 요 확률과 요 확률이 다르지 않다. 네, 물론 굉장히 이상한 함수를 만들면 다르게 만들 수도 있어요. 하지만 뭐 우리가 배우는 항내에서는 그렇지 않다. 네. Okay, so up to now, so we have discussed about the how we define the continuous random variable. And continuous random variable is defined by CDF or PDF. Any question for the PDF? 자, 질문 있으신가요? PDF에 대해서? 네, 질문이 없으시면, 네, 우리 expectation으로 넘어가겠습니다. Okay, so expectation. Okay, so let's think about a continuous random variable x. Then let's discretize this random variable. Okay, so in here, so for convenience, everything starts from 0. Then x can have a value from continuous random variable, have a 0 to infinite. Then we discretize this range of x into the very small regions, delta. So first one is delta, and next slot is 2 delta, and 3 delta, and blah, 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 k delta. Okay? So let's discretize it. Then we assign, define new random variable, discrete random variable y. Y is a discrete. So this is a discrete random variable. X is a continuous random variable. So discrete random variable y has 0 when x equals 0. When x is and 1, 2, 3, blah, blah, blah. So the probability of y is defined by the probability that y is equal to k, let's say defined by probability that k delta, x is between probability of k delta and k plus 1 delta. Let's think about the define y is a discrete and in this way. Okay? Okay, so are you guys following me? Okay, so here, I'm saying again. So here, our goal is to derive expectation of random variable x. Okay, expectation of random variable x. So in order to do that, we discretize x into the y first. Then we're going to approximate expectation of x with the expectation of y. So here, expectation of y, let's use the other one. Maybe this one. Expectation of y is, as it is, y times probability of y is y. So in this case, y is k. Let's see. In this case, y is always k delta, right? K delta, and the probability is okay. So let me get back. Okay, so the probability that y is equal to k delta is so the given in this way. So this is a fx of k plus 1 delta minus fx of k delta, right? So this one, because this is the probability that x is between k delta and k plus 1 delta, so it is written by CDF of the the difference of the CDF between this one. So in here, if we want to calculate this expectation of y, it is when y equals k delta times this probability is that one. So fx of k plus 1 delta minus fx of k delta. It's like this. Okay? Okay, so like this. So we are here. We are here. So basically, the discrete random variable y, the expectation of the y is given as y times probability Pmf of y. And this one is because y is actual value is k delta always. And this py is because py is some discretized probability. So this is a probability between x is between k delta plus delta minus k delta. So this is the probability of y. So expectation of y is calculated in this way. Okay? So, but problem is if delta is very small, this gap, the increasement of this fx by increasing small x by delta, that is calculated by this small fx times this the interval of the small delta. So fx times delta when delta is very small. So basically this so expectation of the y is calculated by k delta. K delta is corresponding to the y, and f times fx of k delta times delta. This is fx of k delta plus delta minus fx of k delta. And this is the probability of y. So they are calculated in, so expectation of y is calculated by in this way. If we describe, so because this y is the discretization of the x, so this is the approximation of the x, ex. So here, if we actually send this delta is the very small value of x, very small value, that means 0, then this summation becomes integration. Okay? And here, this k delta is become x, or actual x, and this is f of x, this is a dx. So it become x times f x of x and dx from minus infinity to infinity. If we send the delta is a very small one. So basically, expectation of the continuous random variable x, Ex, is calculated by integration of x times fx of x. This is the definition of the expectation for the continuous random variable. So it is the very similar to the discrete random variable case. In the discrete random variable case, the expectation of x is calculated by x times its Pmf, and summation over x times its Pmf. And in the continuous random variable, the expectation is calculated very similarly. But instead of the summation, we use integration and x times Pdf. So you can see this expectation is from the same concept. So this is the definition of the expectation. 자, 여러분 그 expectation의 continuous random variable에서 expectation 어떻게 하시는지 이렇게 하시는 겁니다. 그리고 이게 제가 이걸 쭉 설명한 이유는 사실은 그러니까 동등한 컨셉이라는 거예요. 네. 그러니까 그 discrete random variable에서 그 expectation 계산하듯이 똑같이 continuous에서도 계산한다는 뜻입니다. 요 부분에 대해서는 expectation에서는 다시 하겠고요. Okay, so I will review again about the expectation in the next session. And 잠깐 지금 몇 시야? 왜 이렇게 많이 남았지? 저 시계가 빠른가? 11분이니? 그래. 자, 그 마지막으로 우리 중간고사 언제 본다고요? Okay, so midterm again. Midterm is April 21st, Tuesday from 9 a.m. to the 10:15. So in this, and the location gonna be in this classroom. Plus, I'm gonna use another classroom for the convenience. So please, the mark on your calendar. 자, 질문 있으신가요? 네, 질문 없으시면 오늘 수업 여기서 마치고 다음 시간에 expectation부터 다시 하도록 하겠습니다. 예, 수고 많으셨어요. 네.